Okay, right. So we have talked about various types of cohesiveness, cohesion, right? So that can come across different modules of a particular software. But now how you I mean how you one can determine what sort of cohesiveness that a particular module has, so that can be easily um, carried out through this taking this way, right? So what you can do is, let's say one of the function of the module, okay, so you first try to write down a sentence, okay, to describe a particular function of a module, okay. And let's say you have 10 functionalities as part of it, and you can write a sentence, okay, to describe the functionality of that particular module. And let's say if the sentence, whatever the sentence that you have used to describe that particular function, so now if that contains some if that's the sentence is a compound one, let's say you see something like this. So a and B. Okay, so A may be a sentence and B may be another sentence. So you find a compound, right? A and B, this sort of, right? So if you find something like that, there is a possible, that can be a sequential or communicational. Okay, so and let's say, for example, some words you get like this. So after the first sentence, you see something like this. Okay, first this, next that, this sort of words when you see in a sentence, okay, then there is a that is, it has sequential or temporal cohesion, okay, because I told you yesterday only, right? So something will happen first and then something will happen, right? So output of one is given as input to the other, so then you can say that it's a sequential, right? And like some words like and then up and then shut down the certain operations of a particular software, right? So when you find these sort of words, usually you can say that it has temporal cohesion, okay. Now the other term here is coupling, okay. So it actually explains you out how closely two different modules interact, and or how they are interdependent, right? So that is what the measure it gives you, right? Degree of coupling between two modules dependent on their interface complexity, okay. So that means, as I told you before also, so how these two different modules, how it will be going to tell you the degree of interdependency among these two or between these two modules, okay. That is what exactly a coupling, okay. So whenever you see coupling, what exactly most commonly thing come in between a coupling, coupling of two different modules. So usually you see the interfaces, right? So that means if these two modules are very tightly coupled, in that case, so definitely you need to have a and definitely you will have a very complex interface, okay. But if they are very loosely coupled, so in that case maybe the interface will be less complex, okay. So that means you will be only exchanging one or two data items, not many, okay. But if you are going to exchange many data items, probably now at the interface, so complexity will increase, okay. So there are no ways to precisely determine coupling between two modules. However, still, so we can approximately, estimate the degree of coupling. Okay. So there are, 5 types of coupling exist. We'll see one after the other. So usually you have data, stamp, control, common, and content. So these are the 5 different coupling, and the degree of coupling actually increases from data to content when you are going. Okay, so we'll see the what is a data coupling. Okay, so here as part of data coupling, so now we can say the two modules are data coupled. If they communicate, that means these two modules communicate via a elementary data item. Okay, so maybe they will be exchanging some integer or a float or a character sort of data item. Okay, so via a particular elementary data item, you understand in. Okay, so the data item should be program related, not used for control purpose. Okay, so that means sometimes we use some sort of controlling purpose, right? So maybe you have something like this. If you say flag, if flag is equal to 1, so do certain task. If flag is equal to 0, then do certain other task, right? So if if a module A sending a flag sort of data item to the other module, probably that will not be considered here. Okay, so what it will be considered here is, so usually, so these two modules are going to solve a particular problem, right, together, and so that data item is related to that particular problem, right? So it is not usually used for the control purpose, right? So there is a type of coupling which where we will talk about the controlling things also, right? So now, when can you say these two modules are stamp coupled? If they communicate via a composite data item. Maybe you can see in case of Pascal programming language, we say record because it contains certain different number of data items. It is a composite data item. So, or as part of in your C programming language, you see structures or union, right? So those things, right? Because you understand what is a structure. So a structure will have a collection of data items, right? So that is what a struct in C, right? So this sort of composite data item being will be exchanged among these two modules. Then we say that it is a stamp coupled. So in the previous case, so when you say data coupled, so in that case only a elementary data item, an elementary data item, or a single data item. Okay, which will be exchanged, and but that data item should be related to the problem these two modules going to solve together. So now there is a control coupling. Okay, so I told you, right? So here the data from one module is used to direct or control or define the order of instruction of execution in another module, right? So that is what I told you, right? You sending some data, okay, from a module to the other module. As a result, based upon that particular data, now module, you know uh, maybe defined. Okay, so that means if you sending some data, so the execution will be carried out in some order, right? Or if you send another data, so maybe based upon that data, according to that particular data, maybe the order of execution will be different. Okay, that is what. So that means a module is actually having a control over the other module. That is what I say you, right? A flag set in one module and tested in another module. That is what. So flag sort of things should not be used in the data coupling, right? So data coupling as a part of control coupling, so you will be using flags, right? So now you can set these flags so as to have control, right? So you pass a flag value to the other module. Now the condition will be checked if the flag is 1 or 2. So based upon which that particular loop will be executed. I mean, if it is an if else or if it is a while, whatever may be. So you can think of that means one module is going to control the other module based upon by using this data. Okay, so if that sort of things are there, so then we can say it's a control coupling. Okay, now what is a common coupling? So two modules are common coupled if they share global, some global data. That is what. So now if there is a global variable or a global data structure you have defined, and that will be used all of these modules. Okay, then we can say it is a common coupling, right? That means you are going to share a common data. Okay, so all of the modules usually going to share the common data. So those modules are called as common module. Okay, so any doubts of our students? Okay. Now the other one is the last one is a content coupling. Okay, so content coupling exists between two modules if they share code. Okay, now you can think of something like this. Okay, so there may be a code sharing, right? So a portion of the code will be actually handled by one module, so the other portion of the maybe of the code will be handled by another module. If these sort of things are there, then we can say that these two modules hold a content coupling property. Okay, so the degree of coupling that actually increases, right? So now you can understand. Okay, so from when starting from data coupling to content coupling, what is happening? So as part of data coupling, so you have only one data, elementary data, that is being exchanged, right? That means the interface is very simple. Required interface will be very simple. Now you are coming onto a content coupling where these codes are getting shared, okay, not the data. So that means, so now you can understand here, very tightly these, the modules are, coupled. So, I mean, this coupling is actually increasing from, data coupling to content coupling. Now, so as part of design, as I told you, right? So actually what we are getting ultimately we are getting a control hierarchy, okay, where you see the organization of modules, right? So you have a high level modules and then you have a low level modules, right? So I mean, you have, organized all of these modules in such a way that, so the problem can be understood very easily, as well as we can, the complexity or any hidden information is there about the design, so that can also be visible to us. Okay, so those many benefits that we have seen in the previous slides, right? So the most common notation that we use as part of design is the structure chart. So we have already discussed about the structure chart, right? So you have the rectangles and then you have diamond symbols and there is a repetition. So those things I discussed about, I discussed as part of structure chart when we discussed about, when we are having discussions on so design phase, maybe in my initial lectures of software engineering, advanced software engineering. Okay, so usually, whenever you get all these neat arrangements of modules, that means maybe it follows some sort of hierarchy, right? So they essentially has two things, right? One is, I mean, we understand two things are very much, these are the, we can say the most benefits of, getting this thing, right? So you always, whatever the structure chart you get, so you need to see that, if we have low fan out, then it, which is actually the good thing. And if you also have, it also has, it also provides the abstraction. Okay, to the layers. Now you can understand abstraction is what all about, right? So now I mean, as I told you, the high level, modules are decomposed into smaller modules, right? So when you coming from top to the bottom, right? So at the top layer, what you see, you usually see the high level modules, right? But in the bottom layer, so the leaf nodes or the leaf nodes in that particular tree. Okay, so usually they are the very small modules, right, which can be directly implemented by the developers or the programmers, right? Now, so you can see, so when you coming from high level to low level, so the kind of abstraction it has, right? So at a high level, probably you will not be able to know what is all much, okay? But when you coming down, so the information will be uh, more, okay? You will be able to see more information about the problem, right? So now so similarly, you need to have a low fan out, right? That means uh, you have a fan in and fan out, right? Fan in means the number of arrows coming to a particular module, okay? Now fan out means the number of modules going out from that particular module, okay? So when you when let's say there is a module, okay, from that particular module, now there are 4 fan out, okay? If I say there are 4 fan out, that means what? A particular module has has 4 modules, right? That means it has a control, right? Do you understand? Now fan in means, so certain number of functions, okay. So they are going to call the same function module, right? Now you understand. So this way, so usually, so you should always maintain the low fan out. That would be beneficial, okay? Otherwise it will lead to much more confusion, right? So some of the characteristics of this module structure is depth, the number of levels of control, okay? That means, as I told you, right? So what you are doing, so you are going from the top to the bottom, right? So you have certain levels, right? So the top layer, further divided into root node is divided into few other nodes, and those nodes further decomposed into few other nodes, right? And you keep on going to certain leaf nodes, right? That means you have certain level of controls, right? The first one is going to call to the lower level, and that lower level is going to call to its lower level, and that particular lower level is going to call to the lower level of that particular module, okay? So now what is happening, there are different levels of control that you have, okay? So now what is a bit is actually overall span of the control, right? I mean, how long, I mean, that bit will be going to tell you that. So that particular module has, how long it is going to have, the control with all those modules, right? So now, fan out a measure of the number of modules directly controlled by a given module, okay? So that is what the fan out, okay? So that means one module is going to control certain number of modules. I mean, that module is going to call certain number of modules. That means it has a control, right? So fan out exactly going to tell you that measure, okay? So the more number of fan out from a particular module, that means, so a single module has more control over the many, okay? So the fan in indicates how many modules directly invoke a given module. That is what I told you, right? So high fan in represents code reuse, okay? That means what is happening, so many of these modules are calling, okay, to a one module, okay? That means what is happening, so now you can understand from this, okay? There is a super class, okay? And or you can think of something like this, okay? So there is a base class, and there are many derived classes, okay, of that particular base class. So in that case, what is happening? So you are going to use that base class more oftenly, right? That means we are going to reuse. That means there is a fanning, many more fanning, okay? So so it is actually encouraged, okay? That means the fanning, if the more number of fannings that you have, that means it is good, right? But less number of fan outs. That is what I said you. The very beginning I told you. So you need to have low fan out, okay? So a design having modules with a high fan out numbers is not a good design. A module having high fan out lacks cohesion. That is what as I told you, right? So a module that invokes a large number of other modules, okay? So likely to implement several different functions, okay, not likely to perform single cohesive function. That means that is what exactly we are talking about, the fan out only, okay? So a module that controls another module said to be superordinate to it, okay? So that means something, if a module is having control over the other module, then you can say that particular module is a superordinate, okay? So conversely, a module controlled by another module is said to be subordinate, okay? You understand, right? Well, what is subordinate, what is subordinate. Now there is a concept of visibility and layering. Okay, when you're going through this modularity, so let's say for example, if you have a module A, okay, so if that module is said to be visible by another module, okay, so in that case, either A directly or indirectly calls B, okay, so then equal to B, okay. If a module is either directly or indirectly, it is going to call to B, okay. So the layering principles requires modules at a layer can call only the modules immediately below it. That means, as I told you, so the higher level modules can only call to the lower level modules, okay. So that is what exactly the abstraction we have seen. So that is what the layering principle, all about the layering principles, right? Now that is what exactly. So lower level modules do input output and low level functions, okay, and your upper level modules, they do some sort of managerial things, okay. So when I talked about structure chart, so probably I have taken one example of something like this. So taking X and Y data, so we have seen something like this. So so the lower level the lower level modules, they just do like this. So reading the X value or reading Y value, right? These sort of things. So that means they are just simply doing taking some input, carrying out some low level functions, right? So that is not the high level functions, okay. So as I told you, sorting of 10 numbers, okay, that's a only low level function, okay. But you have a high level function where it has many of these low level functions need to be worked together so as to accomplish that high level functions, right? So your lower level modules, so they do only input output and low level function processing, okay. So your higher level modules, they do just manage certain things, right? Like as I told you, right? So your higher level module may be going to call 3 other modules, okay. So you have a fan out of 3. That means what? So the higher level module is going to call to 3 different functions to achieve its function, okay, its functionality, right? So that means, so what it is doing, it is just managing, right? It is calling module A, and then it is calling module B, and then it is calling module C, and then do certain messages being exchanged between these 3 modules, and ultimately it accomplishes a particular task, okay. So that means the high level modules, they do just managerial tasks. Okay. So the principle of abstraction requires lower level modules do not invoke functions of a higher level module. That means usually we have seen that. Okay. So the lower level modules, they never going to call its upper layer modules, right? So only now upper layer modules, they only going to call to the lower layer or lower level modules, right? So this is what exactly a concept of abstraction, right? So as part of layer design. So what is there as part of a high level design? So usually, you have a high level function, okay, and that particular function is going to map to certain number of modules, okay. It is going to map to certain number of modules. That means a particular, high level function. So you can think of like it's again a high level module, and that high level module is exactly map to certain lower level module. You can think of something like this. Okay, so let's say if you have a high level function is fi, and you have mj maybe the lower level modules, right? Each module has a high cohesion, so that means whatever the modules that you have, they are completely, mostly these modules are interdependent. I mean, they have low interdependency. Okay. uh, so coupling among module is as low as possible, right? And they are very much cohesive, right? So that means they are not dependent on the other modules, right? So the low level modules of a particular high level module, okay, so they are independent, and they do have very little less interdependency. Okay, so modules are organized in a neat hierarchy. This is what exactly we have seen. That is the structure chart we talk about, right? So the design approaches, so fundamentally we have two different approaches of this design, right? So one is a function oriented design, the other one is a um, object oriented design. Okay. So then these two design approaches are radically different. They are complementary rather than competing techniques. So I mean, they are not going to compete each other. Okay, these are the two techniques, right? So usually, they are complementary to each other. That means, so if you have a function oriented design, along with which if you have a object oriented design, probably that's a good thing, right? Hmm. So I mean, it is helpful to each other. Okay, but it is not that object oriented design is completely a substitute to the function oriented. It is not like that. Okay, so function oriented approaches has its own advantages and its own place where you can use function oriented things, right? And in certain applications, you really require object oriented approaches, right? But if you can have both of them, so probably it is going to complement each other. Okay, so each technique is applicable at different stages of the design process. Okay, so that is what I uh, discussed, right? So they are useful at different stages of the design process. Now, so what is a function-oriented design? So a system is looked upon as something that performs a set of functions. Okay, so as part of a function-oriented design, what do we see? So we try to see what are the different high-level functions of that particular system. Let's say we are going to develop a system, or a system is going to solve a problem. Okay, going to solve a problem for the customer. So in that case, so what sort of set of functions that will be part of this particular system, right? So starting at this level, in a high level view of the system, each function is successfully refined into more detailed functions, right? So usually you start with the high level functions, right? And then you keep on refining those that particular functions so as to come up with very detailed functions. Okay, detailed number of functions of that particular function. Okay, so functions are mapped to a module structure, right? As I told you before, so as part of structure chart, what you do, so whatever the functions that you have, so you can map to uh, a map to a module structure, right? That means so a high level functions, right? So that means you're saying like this, so these are the modules going to solve these functions. Okay, so this is what, so as part of a module, so you have certain number of functions. That means you have a yeah, so for a system you have a large number of functions, and then you will be mapping that these sort of functions will be solved by this particular module, and these sort of the rest of the maybe functions will be solved by module B. Okay, so you can think in this way, right? So now let's say example here you can see is create new library member. Okay, so let's say you so you wanted to have one function as part of library automation software, right? So there you wanted to create new library member. So whenever you wanted to create a member, okay, that means you so a function. So usually, so what it does, so this particular function, so usually it creates a record for a new member whenever a whenever a person or who wishes to get the library membership, right? So he first comes and when he wants to become a member, usually the first step is done as part of this is, so the record is created, right? A record is created. That means whatever the information he is going to give, let's say he is going to give his name, his mobile number, maybe he will give certain other, maybe address, location. Okay, so these sort of informations will be first created. Okay, like a record. Okay, so that is the first step, right? The second step is, so once this record is created for that particular member, new member, now the library member function should assign a unique membership number. That means you all are going to get a very unique number from the library, right? So now after that, let's say for example, if you have uh, so maybe it is going to give a print out of, if you want to have a if you want to get a membership, right? So definitely you need to pay, because you're going to get some services from the library, right? So as a result, for which you need to pay some money, right? So if you have paid some money towards the membership, so in that case you are going to get a bill of that. Okay, so now these are the various three important functions of this particular new library member function, right? So you have a high level function, and part of this high level function you have three different low level functions, right? So this is the way that you keep on doing, right? So now, so create library member function consists of the following sub functions. That is what we have seen: assign membership number, create a member record, and print bill. These may be three sub functions of that particular library membership. Okay. Now each sub function can further split into more detailed sub functions and so on. It is all depending upon the requirements. Okay. Okay, whether if there is a requirement to divide or the decompose, again further decompose that particular sub function into sub function. Okay, so then you may also get, okay. So the system, yeah, so as part of object oriented design, the system state is completely centralized. Okay, so that means you will be able to access different functions. Okay, so several functions are going, updating, the member records. Okay, right? Because so whenever let's say for example, you one member created now, so a member wants to, you know, become a member, right? A person who wants to become a member. So in that case, you know, the member records, maybe the database that you have, so that will get updated. And similarly, let's say one member wants to, you know, withdraw the membership. So in that case, so when you delete the member, so some then these records will be updated, right? So like, so in any point of time, maybe you wanted to make changes to the, you know, member record. That means you wanted to update the member record, right? So that means you wanted to, maybe something like this, you wanted to update the address of a particular member, right? So now what is happening? So here you have a very centralized state. That means you have a some database sort of thing, right? You can think of, right? You have all these records, right? And these all different functions, whatever you thought of, they are going to make changes to the state. Okay. So this is the reason why. So in function oriented design, so it is the state is very centralized. Okay. But in case of object oriented, so your state will be distributed, because you know, each and every object will carry its own data. Okay, that's the way that you know, we are actually going to make a difference. Okay. So, so now several function oriented design approaches have been developed, right? So there is a Constantine Jordan approach, okay, and there is a Jackson structured, you know, design approach. So proposed in the year 1975. I told you before also, 1 year old methodology is there. So there is a methodology, worth stepwise refinement methodology, Hatley and Purvis methodology. So there are many object-oriented design approaches have been developed over the years, right? So maybe we are going through one of them, right? Maybe the structured design, that is what we have seen is, we'll talk about this, you know, maybe in the next to next lecture. Okay. The system is viewed as a so as part of object oriented design, the system is viewed as a collection of objects. That is what you know. Okay. So as part of object oriented system, so usually, so your system is completely composed of many objects. Okay. So the system state is decentralized among the objects. That means, you know, so each and every object is going to make updates within that particular object. Okay. So each and every object will carry its own attributes, right? And it has its own operations, right? So are the methods, what we call, right? And that, you know, object is going to make changes to its own data, right? So now the state is here decentralized. It is nothing like, you know, you have centralized structure, where in case of function oriented, right? So each object state information, right? So that, you know, so each and every, you know, object has its own name, has its own number of member functions. Okay. Like methods or the functions, right? It has its own attributes, right? So that is the way. So each and every object gets a unique name or address, right? Identifier, object identifier, right? So as part of object-oriented design, we'll see an example of this library automation software. Each library member is separate object, right? So here, so each and every library member can be seen as a separate object, because so it's a real world entity, right? We library member as a real world entity, right? So that can be represented as an object, right? With its own data and functions, right? Each and every library member will have its own data and the functions. Okay. Now these functions defined for one object, right? Cannot directly refer to or change data of other objects, right? So usually, so those data is essentially for each and every object. Okay. So objects have their own internal data. That is what exactly I told you before. So that means they usually define their own state. right? Now it is the distributed state approach. Here you can see now, right? Similar objects constitute a class. Now, so so as there is as part of object oriented approach, you see there is a class. Okay, so so the similar kind of objects, okay, they will be part of a particular class. Okay, so you can think of like this. Okay, so let's say if you say color is the best example of a class, right? So now yellow, blue, red, these are the all instances of that particular color. Now each every these entities, colored entities, so they do have similar sort of properties, right? You can think of like, so there are many examples of class and objects, probably you understand them, right? Any doubts so far, students, here?
No, sir.
No. Okay. So how many of you gone through any object oriented programming language in the past? Yeah, just tell me who has not gone through. Okay, there are big list of students who have gone through object-oriented programming language, but just tell me who has not gone through object-oriented programming languages. Is there anyone? Okay, fine. That means so every one of you, gone through object-oriented programming language like C++ or Java, or any. Right. So now, so these classes may inherit some features, right, from its superclasses. So that means you have some superclass, right, and you have some classes, and from those superclass means that superclass, usually in the name when you see super, that means you can understand, right? It will have many more interesting features, right? So now those features will be used by by certain other classes, right? So that is what we call as a inheritance. Okay, so inheritance means we are trying to inherit certain features from some other classes, right? So conceptually objects communicate by message passing. So usually here, so these you have many number of objects, right? Now these objects are going to talk to each other through message passing, and through this, I mean by communicating, through this communication. So usually, let's say you have a system, and that system by by certain number of objects communicating among themselves. Okay, so that is what we do in as part of any object oriented system, right? So we try to see some comparisons between these two techniques approaches, right? So, so as part of unlike function oriented design, so in object oriented design, the basic abstraction is not functions. Okay, so usually as part of function oriented design, what I told you, so you will be going to see certain number of functions. Okay, but here the basic abstraction is not that as part of object oriented design, because we have here the basic abstraction here is the objects. Okay, but the real world entities such as employee, picture, machine, radar, whatever the here the basic abstraction is your real world entities like the objects. Okay, so you can say example is employee, picture, machine, radar system, these are all entities, right? So now you will be seeing here the entities, right, in terms of entities, not in terms of function difference. In object-oriented design, software is not developed by designing functions such as update, okay, employee record, get employee address. So these things, so usually you have these sort of things, right? You have these functions, but these functions are part of those objects, right? So let's say, in case of software, function oriented design, what will happen? You will have some functions, right? You update the employee record, you need to get the employee address. So these are the various functions, okay? But here what will happen? You will have an employee, part of this employee, so you will have all those things, right? Update employee, get employee address, so those things will be part of, right? And similarly there will be some functions which will be part of departments. So that means, so by designing some objects, so you will have ultimately certain number of functions. So each and every object will have some attributes as well as characteristics, right? So you have some attributes and some properties, right? So if you talk, you probably understand, right? If you do not understand, you just interrupt me any point of time. Otherwise, I understand that you are following me and you understand everything, whatever I'm saying. Okay. So, and sometimes, you should be asking also, you should ask something, right? Otherwise, I feel mostly very monotonic, right? Boring. So when you ask something, maybe help me in, um, explaining the same thing in a very better way, okay? Or I try to explain that in by giving some other example so that you will be able to understand, right? So now, according to Grady Booth, so he actually gives the fundamental difference. So what he says is, so is part of object oriented, how these two things, design techniques are, the approaches are different, right? So by saying, identify webs if you are after procedural design. Okay, that means procedural design means function oriented design, where you have procedures, right, or the functions, right? So let's say, for example, you have been given a document, right? You have been given a document or the SRS document, right? Now, somebody will ask you, so come up with a function-oriented design of that particular SRS document by taking that SRS document. In that case, what you will be doing? First thing, you will be trying to find what are the different operations or the functions. Okay, what are the functions? So how will you find those functions from that particular document, SRS document? So usually you will be underlining the verbs. Okay, verbs are the ones actually they tells you the functions. Okay, so right. So now the nouns, if you are going to see, so then probably if you're asked to, if you see the nouns, then they will be part of object oriented design, because you see each and every object so will have a name, okay, but each and every function probably will be given in terms of verbs. Okay, that is what the difference. So this is the way that you can see. So in object oriented design, state information is not saved in a centralized data, okay, but is distributed among the objects of the system, is what we have seen, right? So the same thing, another example you can see. So in an employee payroll system, the following can be global data. So names of the employee may be a global data. Okay, their code numbers, maybe they've been given some codes, or their basic salaries, right? So the basic salary for many employees will be the same thing, right? But maybe because of the promotions, maybe you are going to get higher pays and all, so that will be different. Your basic salary may be the same for everyone, right? So whereas in the object oriented systems, data is distributed among different employee objects of the system. Okay, so now so here you have all data, global data, and this global data will be shared as part of function oriented. That is the reason why I said you this is a state is very centralized, whereas in case of object-oriented system, the state is distributed because each and every object will have its own data. Okay. Now objects communicate by message passing. That is what you know if you have gone through any programming languages, right? Object oriented programming language, right? You have certain objects and these objects will carry their own data, right? And now so they change the state by exchanging information by through message passing. Okay, so you through message passing, so you will be able to um, you know able to communicate, right? So probably you understand this in part of Java programming language. There is a RMI concept, right? Remote method invocations, right? So that means different objects at different point, different objects available in different, I know, like are these objects are distributed over the network, right? Now you have some software at some place, you have the other parts of a software maybe in the other place, right? So they have certain number of objects, that particular part has certain other number of objects. Now these objects are actually talking to each other over the network. So that is what exactly, so each and every objects can try to access the member functions of other objects, right? So that is what exactly done, not locally, so you are doing over the network. Okay, that is what we call as RMI method. Yes.
Sir, in Java, there is also a concept called serializable. So in that we send object as byte stream. Can that be considered the same as we communicate here? Like object communicate by message passing. We are sending
You
object as
see,
byte stream.
so just tell me, so what do you understand by serializable? Okay.
So we are converting our whole class, the object, into a byte stream, then sending, and then reconverting back to the desired class.
Okay, okay, right. So that means what you're doing is, so that is, yeah. So that means what you are doing. So you storing your data in the format in the form of bytes, right, in your computer, right? So whenever so because you see, so you each and every object they have their own state, right, as I told you, but those state is stored at some place, right, maybe in your computer, right? So the information is kept in the form of bytes and all, right? So what you doing is you carry those data, and when you communicate between two objects, you send your data. Okay. And after the object is received that particular data, now that data will be stored at some point of time, right? So it will be storing in a memory, right? So then again your computer understands by streaming or bit streaming, whatever may be, right? So you actually serialize your data and you deserialize your data, right? So that is what exactly the serializability, right? So that means here we are talking about message passing, right? So we pass message among I mean between two objects. Okay. So this way, is it clear?
Yes, sir.
So of course somewhere the functions must be implemented. Okay, those functions are usually associated with specific real world entities, right? So directly access only part of the system state information. So you can see, you can understand, right? So from these two statements, right? So the function oriented techniques, so group functions together. So you understand. So a higher level function is a group of
Sir, you're muted.
they operate on certain number of functions together. Okay, so that is what. So we take an example of a automated fire alarm system for a large building. So you understand fire alarm systems are the ones, okay? So they generate alarms whenever any fire caught in a large building, right? So right. So we'll take this example and try to see how how you define using a object-oriented approach and how you define the same problem using function-oriented design. Okay. So so we need to develop a computerized file alarm system for a large multi-story building. You understand there are 80 floors and 1,000 rooms in the building. Okay. And with each and every room is fitted with a smoke detectors, right? And fire alarms, right? So whenever these detectors, they detect the smoke inside the building, okay, I mean room, so it will generate a fire alarm, right? The fire alarm system would monitor the status of the smoke detectors, right? So that fire alarm system keep on monitoring the status of the smoke detector whenever whenever there is a something like if the smoke detector detects something usual, so in that case it is going to report. Okay, so your fire alarm system is going to report that, right? So whenever fire condition is reported by the smoke detector, right, the fire alarm system should determine the location from which the fire condition was reported. Okay. So and then it sound the alarms in the neighboring locations. Okay, so in the neighboring locations it is going to give a sound that this particular location, so there is a fire. That means others will be aware of this. Okay, so this sort of software that we wanted to develop. So right, so as part of fire alarm system, so there is a flash and an alarm message on the computer console, maybe to the neighbor computer, so it is going to give a message, right? Firefighting personnel man the console round, so they may be going through the people going through those console, right? So whenever they see any message coming out, right, so emergency message, in that case the firefighting people, they will be going and act accordingly, right? So after a fire condition has been successfully handled, the fire alarm system should let fire fighting personnel reset the alarm, right? So once that people who have come to that particular place, and then they can reset that. Okay, now for this thing you can think of, so you will have some detector status like this. Okay, so you can have some variables, right? Alarm status also you can represent with a variable. Detector locations, maybe as I told you, 1,000 rooms, so you may be giving unique identifier to each and every room, maybe 1 to 1,000 or 999, so that will tell you that which particular location and alarm locations. So this is a way that you can think of, right? So neighbor alarm, so that means for each and every room you have 10 number of neighbors. That means you need to have a two-dimensional array, right? So one of one, that means first room ka first neighbor. One of two, so that means first room ka second neighbor. So this way, and you have certain number of operations like this. Okay, so get detector location where it was happened, so determine the neighbor, who are the neighbor for that particular, and then you going to ring that particular alarm. So this is one function, and the other function is going to allow you to reset the alarm. Okay, so the and report the fire location where that particular fire was caught. So this is the way that you have the data as well as some operations, right? Now as part of object oriented, so you will have attributes and operations, right? So you can you have certain attributes like status, location, neighbors, so they are the various attributes. Okay. And now you have some operations like um, is part of class detector, so you can create a object, you can sense status, you get the location of that particular detector, and then finding the neighbors, so those things can be part of that particular class detector. Similarly, you have a class alarm also, right? So as part of class alarm, so where that particular alarm is there, location and its status, right? And so these are the two, maybe two attributes, right? And operation can be ring the alarm, get the location of that particular alarm, right? And reset the alarm. So these are the associated with that class. Okay. So now, so as part of any object-oriented program, you need to appropriately create the number of instances of those objects, okay, classes, okay. So, and those instances will be talking to each other, going to solve a particular problem, okay, clear? So, in the function-oriented, the state is centralized, whereas in case of object-oriented, the state is distributed. These are the very important difference, okay. And so usually as part of object oriented design, so you see there is a top down function oriented approach again, okay. So how it happens, so as a part of a particular class you will have certain number of methods again, okay. So like you can accordingly follow some sort of function oriented design approach within the class, okay, that is what we say. So you have 10 number of methods, so you can have again a procedural sort of things, because as part of a particular class or an object also you have certain number of methods, right? Now you within that particular object you or the class, now you can come up with some sort of function oriented approach again, okay. So though outwardly a system may appear to have been developed in object oriented fashion, but inside each class there is a small hierarchy of function designed in a top down manner. So that is what I told you, right? So the summary here, we have seen certain activities which are carried out part of software design phase, okay, and then what really informations need to be produced at the end of each design phase, right? Because by with this information, by taking this information, a programmer can implement the design, given design, using a programming language, right? So and we characterize some features of good software design. So you should have high fanning, but you need to have very low fan out, right? So you need to have very high cohesion, but you need to have very low coupling, as well as it has certain level of abstractions, right? So control of hierarchy. So we have seen these all things through software design, right? We have also seen different classifications of cohesion and coupling, and we have seen the difference between these two approaches, function and object oriented, okay. So these two approaches are not competing, but they are complementary to each other. This is what the main importance of these studying these two different activities, okay, these approaches, okay. So today we stop here. So any doubts of our students? Can any doubt?
No, sir.
Okay. So next Wednesday, so I can take one test, okay. So till now whatever has covered, so I will take a test on Wednesday again, okay. So there will be a class test on Wednesday. So Wednesday or when you want.
So Friday would be good because we already have a test for FCS on Monday, so we need more time to prepare.
Oh, you are getting Saturday, Sunday enough time.
Like we already have a test on Monday, that's why.
ठीक है, every day you give one test now. What is the problem? If you give many more tests, then it would be better for you, na? You get yourself assessed in a better way. Yeah. How far I said you, the more test you are going to give, it is better for you. Because your average goes better. Even if you doesn't perform well in one exam, so if you get good marks in other, so still you can further improve. But if I take only one test and you performed very poor, then what will happen? Your marks is you're going to get less marks, right? So that is why. Anyway, so so it's a Friday or next Friday or Wednesday?
Friday.
Friday. Okay, चलो. So Friday होगा एग्जाम, ठीक है?
Sir,
Okay.
everything up till this point?
Yeah.
Okay, sir.
So I'll write a mail. Okay, whatever the syllabus content and everything I'll write. Okay, and also I upload today all the videos. Okay, slides, everything. Then I will write a mail. So when the exam will be. Okay. Okay, so I preferably go with Friday. Go on Friday. Okay. ठीक है.
Sir, what about the lab, sir? ASE lab?
Labs तो अब तक हुआ नहीं कोई.